Hello everyone, welcome back again. Today we're going to have a look at the grade 12 November question paper for mathematics paper 1. This is 2022. That is, we're going to have a look at question 2, and the statement of question 2 reads as follows. The first term of a geometric series is 14 and the sixth term is 448. Okay, so question 2, as we all know, or as we all should try to know, is going to deal with patterns. By patterns, I mean different series, and that is your geometric series, arithmetic sequences, and basically all kinds of sequences. What is special about this question is that we're dealing with a geometric series. So what is a geometric series? Just a quick recap. A geometric series is a series that, if for instance we have the first term A, we have a second term B, C, and it continues up until let's say X. Things to note in here is that A is the first term. What is term? Term, we normally denote it as n. So n, when n is equal to 1, that is the first term. When it's equal to 2, it's the second term. When it's equal to the value that we know, let's say x, or we say n. So, okay, no? So x is the value that is in that term. But what is the term here? That is our nth term. So we have a value in the first term, which is A. In the second term, we have B, C. But in the nth term, the n can be 7, n can be 8, n can be the 100th term. But we refer to it as nth term, and it holds the value of x. So n1, first term, nth term, is the term that we don't know. But now for geometric series, we have that there we cannot find a difference between the first and the second term. So we cannot describe the series or the sequence by just looking at what is the difference here, and what is the difference there. Because even if we continue, so this is the first difference, we go to the second difference, third, up to the ninth difference, we won't find a sequence. We won't say, for instance, if we look at the quadratic sequences, we will find that the second difference is constant. For a geometric series, we won't find something like that. For geometric, we deal with ratios. A geometric series will have that if we were to divide the second term with the first term, so B over A, this value should be the same as dividing C and we divide it by B, or we divide, say if we had the C here or D here, D divided by C. So we call this a ratio R. So geometric series is described by the ratio between consecutive terms. So if we look at term number 7, then we'll look at the ratio between 7 and 8 and 6. So the term 7 divided by the term the value in the term 6. So that is a ratio. Another thing is the first term. First term defines or forms part of the description of a geometric series. And the first term we denote it as A. And A is the first term. It happens here that the value is A, but generally A, we call it the value that is in the first term. And all of this is described by Tn equals to A Rn minus 1. What is this? This says that term number n, the value that is in the nth term. This is the value that is in the nth term is described by this equation, a multiplied by r to the power of that term number that we would like to find this value, minus 1. So it means that when I introduced you here between x and n, nth term is the term that we'll want, but we sometimes don't know what will be the value in there. So we have an equation that will help us figure out what is that value if we know what the term number is. Or alternatively, we can find what the term number is if we know the value, what that value is. So this is the equation, and we substitute basically by the a and r value to find the sequence. Let's go to the first question. First question is asking us to calculate the value of the constant ratio r. So as I've just described to you, we have this equation, and we are told here three things. That the first term of the geometric series, so a is equal to 14, is written in the statement. We are also told that the sixth term, so if we look here, then term number will be 6. So for n equals to 6, we have that x value is equal to 448. These two come together. So for the term number 6, the value that is in that term number is 448. And they're asking us to find the ratio r. So like I told you, we already know that this is what describes. So this is what describes the geometric series. So how can we find that equation? So Tn is equal to 14, the ratio r, n minus 1. So how can we find the value of r? So we are given that for us to figure out the value x that is equal to 48, we needed to substitute by the term number 6 in this equation. So it's true that if we were to say what is the value that is in that term, which is 448, and we say for term number 6, if we were to substitute 6 in here and the unknown ratio times by 14, so we should be able to get 448. But in this case, we don't have the value of r. So it means that the same is true that if we were to substitute by 6 minus 1 in here, we can figure out what the ratio is. So to solve that, we have divided by 14. 14. This cancels. So we have r, then 6 minus 1 is going to be 5. And then we have r, so 48 over 14. And that's equals to 32. So how do we find the value of r? So I'm going to try to go back to the basics. If you already know, you can already just go to the final answer. So in order to find for this kind of equation, we can find the value of r by this way. So this is everything that will aid to the answer. If we're trying to look for a value of x that is raised by a certain number a, we already know that it's going to give us, let's say, value z. I'm going to repeat, we don't know what this base, this is called a base and this is the exponent. We don't know the base, but we know the exponent and we know what the answer should be. We can find what that base is by raising this exponential function by a reciprocal of that value a. So reciprocal will be 1 divided by whatever that is. So here in this is a, we do the same on the right hand side. So 1 over a. So a here will cancel a, and therefore x is equal to z to the power of 1 over a. Same can happen in here. So r to the power 5 divide, we raise to the power 5, 1 over 5. So r is equal to 32 to the power of 1 over 5. That is 2. And that is the end of question number 2.1.1. Let's move to the next question. Alright, so the next question is as follows. Determine the number of consecutive terms that must be added in the first 6 terms of the series in order to obtain a sum of 114,674. So the series, if you remember, was guided by this equation. Tn is equal to, this is for 2.1.2. Tn is equal to, that was 14 ratio 2 n minus 1. So now we are being asked to, so let's analyze the question. How many terms can we add after already summing the first 6 terms? How many can we add that are consecutive so that we get the final answer as 114,674? So here we're looking for a sum of terms that, if we were to say those terms, let's say from term number 7 up until term number 100, if we were to sum those values and then we add to whatever sum that we know for the first 6 terms, these, how many of those term numbers can we add in order to find that value? But the best way to analyze this question is that, okay, we already have term number 1, n equals to 1 up to n equals to 6. Now we're trying to find out how many other terms can we add. So term number 7 up to term number, we don't know. So this is term number 7 and this is term number x. This is not the value that is in that term, but just the term number. So we're being asked how many of these, so the values that are in there, how many, so if we're to sum those values and then we add to the sum of these, how many do we need in order to get 114,674? So the best way to look at it is like, okay, how about we find a sum that can give us those that sum that is given there. So how can we find the number of terms that are needed for that sum? And then from there we can basically say, so these are the number of terms that are needed for this sum. Take 6 from those terms, how many are left? Then those will be the values, the terms that we need to add in order to get to that sum. So what is the equation of the sum for a geometric series? So Sn is equal to a Rn minus 1 R minus 1, whereby a is our first value, R is the ratio, n minus 1, and here we have 2 minus 1, so ratio 2 minus 1. So they are saying that for n number of terms, if we sum the values that are in there, we can get 114,674. So if we were to sum n values, we can get 114,674. So, but this sum here is guided by this equation. And what is that equation? 2 minus 1 is 1, so this is all equals to 14, 2n minus 1. So what then we need to find is that how many of those terms are needed. That's the term number in there. And let's say we get this term number as 20. If it's 20, from the 6 terms that we already know that we can, if we were to subtract those 6 terms, we're going to have how many values? 14 terms that are added on top of the 6 terms, so to get to this sum. So how do we then solve this? So we divide by 14 here. So 2n minus 1 is equal to, you can divide this. So this is 8191. So we take 1 to that side, it's going to be 2 to the power of n, 8192. how do we find the value n? For this, so just to jog your memory again, if we have a known base, this is the base and this is the exponent. If we have a known base a, so let me say if we have a known base a that is raised by an unknown value, and this is giving us a certain value z, how can we find that exponent? That's where we use the logarithms. So a log with a base that is equal to the base here. So a log base a, and then this, we do it on both sides, log base a. We can then say, so the rules of the log is that then we can take this exponent 2 before the log, so it's going to be x log a and a equals to log a and z. Therefore, and also, so we know that a log is a and a, this will cancel and become 1. So in your calculator, you press the log that has the square here and the square here. So we put a here and whatever that value is, then we're going to find our x value. So we do the same also here. We have 2, so we say log log 2 base 2, then n is gonna come this side is equal to log 28192. Therefore, this will cancel and become 1. You can prove it by punching it in your calculator. N is gonna be equal to the value that we have here. Okay, so n is equal to 13. What is that n? N, if we look at this equation, if we were to add 13 terms of this series, we are going to get 114,674. But we already have 6 terms, so how many terms will be added on top of the 6 to get to the 13? So you say, therefore, we need 13 minus 6 terms, which is we need 7 terms. 7 terms need to be added. Hopefully you got that. So 7 terms need to be added on top of the 6 terms that already exist in order to get a sum of that one. Let's move over to the next question. Okay. The next question reads as follows. If the first term of another series is 448 and the sixth term is 14, calculate the sum to infinity of the new series. So A now is equal to 448, and they're saying that for n equals to 6, we have the value x equals to 14. So they're saying we must find the sum to infinity. Okay. So what is, just following up on the previous questions, we are looking here for the sum to infinity. But this is a different geometric series now. We have a value a, 448, and then we have 14 for the n equals to 6. Which means, so first of all, the equation that guides us for sum to infinity of a geometric series is sum to infinity is equal to a over 1 minus r. And this is strictly for values of r. So if r is between -1 and 1. So that's for those kind of ratios. And we already know here that if the first term is 448 and the sixth term is 14, then we already know that the ratio is way less than 1 because we are decreasing as we go forward. But now we don't have the value of r. How can we find the value of r? So if you go back to the same approach you used for the first question, Tn equals to Arn minus 1. We have that for n equals to 6, T6 for 448 here, times by ratio. For n equals to 6 minus 1, we have the answer as 14. So how can we find the value of R? So R, 14 over 448. So R, we calculate using the same approach. So R is that value, 14 over 448 to the power of 1 over 5. You can punch that in your calculator. So now we can find what is the sum to infinity. Sum to infinity, we already have A, which is 448, and R is this value. So if you substitute there by 448 over 1 minus this value, 14, 448, 1 over 5. The answer is going to be the answer is 896. That is our answer, and we can move to the next question. Question 2.2. The statement of the equation is that if we sum that 1 over 3p plus 1 over 6 up to the kth value of p, then we're going to get 20 and 1 over 6. So they are saying we must determine the value of k. All right. So this is a sequence. This is a sequence, and if we are to sum each substitution of p from 0 to the kth, if we were to sum that, we are going to get 20 and 1 over 6. So what then this means is that, so the best approach is to try and find that pattern. If you know that pattern, and you can categorize it, whether it's a geometric, an arithmetic sequence, or whatever, and then we can then say, okay, how can we sum all of these, and that will help us to find the kth, so the value k. So let's try just maybe the first 4 terms, and try to find out what kind of a sequence is this. So we have the equation as, the equation of the series is that we have 1 over 3p plus 1 over 6. This is p. So if you substitute by p equals to 0, so the first term is when p is equal to 0. So that's going to be 1 over 3, 0 plus 1 over 6, and that is equal to 1 over 6. That's our first term. The second term, n equals to 2, is when p is equal to 1. So if you substitute there, 1 over 3, 1 plus 1 over 6, then we get, gonna be 1 over 2, yes. If we look for n equals to 3, n equals to 3 is p equals to 2. Why am I saying all of this? If p was starting from 1, then p will correspond to our term number. Know that p is not a term number. P is a value in this equation, which will tell us about, will give us information about the whole sequence. So for n equals to 3, p equals to 2, we have 1 over 3, and 2 plus 1 over 6 equals to it's going to be 5 over 6. So this carries on and on up until we get to because now we're looking for k. So there's a point where p is equal to k. If p is equal to k, we already know that n is always p plus 1. So therefore n will be k plus 1. So get this, we said for value of, for the first term, p is equal to 0. Second term, and so on. So it means for p equals to k, it means n must just be 1 extra or more than p. So that's k equals to 1. So we have 1 over 3 k plus 1 over 6. That tells us about that certain term number. Alright, so we already have this sequence and it's like this. When I try to remember it, we have a sequence like this. 1 over 6, we have 1 over 2, we have 5 over 6. And it goes on and on up until what? 1 over 3 k plus 1 over 6. We are summing this up until that value. So a sum. So first of all, we need to find whether this is a geometric or an arithmetic sequence, so we know what kind of a summing equation we can use. So if we find a difference in here, if we find a difference and it's the same, then we already know we're going to go with the arithmetic sequence. If we find a ratio that is the only one that better describes this, then we're going to go for a geometric series and so on. So the difference here is 1 over 3. Also, here is going to be 1 over 3. Yes. And so on. So if then we say, so let's just confirm, so 1 over 2. So we already know that this has to continue. So 1 over 3. So we already are settling on the first difference. We're already having the same thing. So it means that this is just a simple arithmetic sequence. And for arithmetic sequence, we have that for a sum of n terms, we are guided by what is the equation? So for sum of n over 2, 2a plus n minus 1 d. So get this. They are saying that if we sum all of these up to that, and this is term 1, n equals to 1, and this is up to n equals to k plus 1. Remember from what I tried to describe previously. Please go back there to just familiarize yourself. So this is n equals to 1, n equals to 2, up to n equals to k plus 1. So if we are to sum those values, we are going to get to 21 over 6. And this can also be written as 6 times 20, which is 120 plus 1. So this is the same as 121 over 6. So we already know the first term, the value of the first term. We already know the difference is 1 over 3. So we can figure out how this looks like. So n over 2 into 2 times 1 over 6 plus n minus 1, 1 over 3. This should all equals to 121 over 6. So we can continue here. N over 2, 2 over 3 is 1 over 3 plus, and then we multiply this throughout, so we have 1 over 3n minus 1 over 3, and this should all equals to 121 over 6. Oh, we already see that this can cancel out, and we are left with n over 2 multiplied by n over 3. So this is n squared over 6 equals to 121 over 6. So therefore 6 will cancel each other, and the value of n is going to be square root here. When you take a square root, know that the possible values can be plus or minus. So n will be, so what is the root of 121? It's 11. So n can either be plus or minus 11. But you have to now make a decision here that are you going with n equals to positive 11 or minus 11. So we already know that we started with n equals to 1. We can never go back. We can only have a positive value of n. That will make sense for our series. So we are going to choose n equals to positive 1. But the question asked us about the value of k. So remember that n is equal to k plus 1. So this should all equals to k plus 1. So n is always 1 extra than the value of p. So therefore k here is equal to 11 minus 1. So k equals to 10. And that's it for today. Hope you enjoyed it. Please leave questions on the comment section and we'll take it from there. Thank you.